Our dear learners, I will welcome you back and I thank you for embracing the platform. Indeed, it is the way to go. We are talking advanced level mathematics and we are talking pure mathematics. Pure mathematics, that is paper 1, Ugandan students. This is paper what? This is paper 1. And today we are going to look at vectors. Today we are looking at vectors, and our lesson 1 will be basically to get introduced to vectors. Our lesson 1 we are going to basically get introduced to vectors, and we are saying that we shall be looking at the relationship between scalars and vectors in particular. And vectors in particular. It's upon that we shall go into the details of 3D and look at lines and planes. Lines and planes. Now, I've talked of scalars and then vectors, because if we are talking vectors, we cannot just talk about vectors without looking at both scalars and vectors. So, for scalars are quantities defined by only the magnitude, whereas vectors are quantities defined by magnitude and direction. So I'm right to say that vectors are scalar quantities with a defined direction. Since scalars are quantities defined by only the magnitude and vectors are quantities defined by both the magnitude and direction, so I'm right to say that vectors are scalar quantities with a defined direction, are scalar quantities with a defined direction. So from there, we are going to look at how to represent vectors. Representation of vectors. Representation of vectors. So we can say that vectors can graphically be represented by a straight line with an arrow on it. With an arrow on it. So if this is point A and this is point B, and that is an arrow, so we can say that it can be represented with an arrow or a straight line with an arrow, and then we are saying the direction of the vector from A to B, the direction of the vector from A to B, is shown by an arrow. Is shown by an arrow, and the magnitude of the vector AB, is the length from A to B, or the distance from A to B. Since we are saying vectors are defined by both magnitude and direction, so we are talking about the direction. That direction is indicated by this arrow, and then the magnitude of this vector AB is that distance from point A to point what? To point B. Now, vectors are represented by two capital letters with an arrow on top, i.e. AB. But in typed script C, we use bold letters. We use bold capital letters. We use bold capital letters to indicate the same. I've said when representing vectors without using the graphical way, when representing vectors, you can use two capital letters with an arrow on top of them. But in typed scripts, the moment you find two bold letters, two bold capital letters, those two capital letters mean we are still talking about vectors. Now, when does the small letter come in? That's what I want to talk about. That's what I want to talk about. Position vectors. position vectors. A vector which represents or which indicates the location or position of a given point. This is a vector which indicates the position of a point, with respect to an arbitrary reference point such as the origin. I've said this is a vector which indicates the position of a point with respect to an arbitrary reference point such as the origin. Let's consider the diagram below. So, when you look at this is the origin. When you look at our point A, this is a point A. With respect to the origin, we can say that the position vector of point A, with respect to O is OA. So OA is a vector. And based on what we've talked about there under representation, two capital letters, that is the O, which is the origin, with the A. Now, I'm bringing in the issue of small letters because I talked about it there. I said I would bring in small letters. So the position vector of point A is OA. O, small a, but with an arrow. O, small a, sorry, with a symbol underneath or below it. So that means if we don't use two capital letters with an arrow on top, we can use small letters with a symbol below those two small letters, with a symbol or with that symbol there, but it is below. So OA, so we can say therefore OA is the same as A. But I want to emphasize one particular thing. That is none other than typed scripts. In typed scripts, you'll find this OA being bold without that arrow on top. Or if you are taking this small letter, still you'll find it bold without that symbol below it. That is something I wanted to emphasize there under representation alongside position vectors. I've said that a position vector of any point is OA. So OA is the same as A. But I want to emphasize one particular thing. That is none other than typed scripts. In typed scripts, you'll find this OA being bold without that arrow on top. Or if you are taking this small letter, still you'll find it bold without that symbol below it. That is something I wanted to emphasize there under representation alongside position vectors. I've said that a position vector of any point is the position of that point with respect to the origin. Position of that point with respect to the origin. Now, having said that, let's talk about displacement of a vector. I think we can talk about addition and subtraction of vectors. Addition and subtraction of vectors. For two vectors, for vectors given below, if we have OA, which is 2, 4, and OB, which is -2, 5. OA plus OB will be given by 2, 4 plus -2, 5, which is when we add the corresponding components. So the 2 will add to the negative, trying to get a 0. Then the 5 will add to a 4 and you get a 9. Now this is 1. If we look at OB minus OA, OB minus OA is giving us, OB is -2, 5 minus 2, 4. So if we subtract, still we subtract corresponding components. So 2 minus 2, you'll get a -4. Then 5 minus 4, you'll get a 1. If we consider vectors, A, which is 1, 3, and B, which is 4, 2, then C, which is 5, -1. If you want to find, for instance, A plus B minus C, A plus B minus what? Minus C. We have our vector A, we have our vector B, we have our vector C. This is a matter of substituting here and you do the routine. But the key point is we subtract or add corresponding components. We subtract or add corresponding components. So this is 1, 3 plus 4, 2, then minus 5, -1. So what do we have? We start by adding. So we do have 1 plus 4, you get a 5. Then 3 plus 2, you get a 5. Then minus 5, then -1. So this one will give you a 0, 6. So that is addition and subtraction. Ladies and gentlemen, we are picking it up from there in our next lesson.